Alright, grade 12s, good morning. Thank you guys for coming back. Just like yesterday, I hope that today's session will be meaningful. Remember that we are about 130 people or so in here, so we all have different backgrounds, and I know for a fact that there are some of you who I won't absolutely satisfy. But I just want to remind you guys once again about the goal of this session, and that is exam preparation, okay? Again, guys, I'm not trying to teach you the science or teach you the chemistry. I'm here to try to help you to write an exam successfully so that you avoid making silly mistakes and so on, okay? So, guys, if you take a look at the notes, you're going to now see at the back of the notes is where the chemistry begins. So if you look at the summary booklet, on page 13, you're going to see organic chemistry begins. Okay, page 13 of the summary booklet. And for those of you that were struggling to find my email address, you're going to find it on every page. So if you look at this page, it's over here at the bottom. It's saltedphoton@gmail.com. And again, that is just for me to send you guys documents. I won't spam your account. I will not send anything other than the documents that you request, okay? So that is the email. On this page, guys, you're going to see a lot of the organic chemistry summarized. We probably will not get enough time in this session to go through organic chemistry problems, okay? I'm telling you guys that up front. But you're going to see there are a whole lot of summaries, nomenclature rules, physical properties in organic chemistry, and then those organic chemistry reactions that you guys tend to battle with, okay? This is a summary, and please do not take everything in here as a fact compared to your notes. I'm just a human. I did my best to put this together, but make sure that the information is correct. And guys, if you find any mistakes, email me, okay, so that we can make the document better for the next group of grade 12s that come next year, okay? So, to start off, like I said, I'm here to help you guys prepare for your exams, but I believe that I need to empower you guys and not just make you guys rely on me. Yesterday I made this example of learners coming into the classroom and being completely blank, and I am the sole source of the information that they require. But that's not true, okay? You guys are human beings. You have a whole lot of knowledge somewhere that you get outside of the classroom, from the internet, from other teachers, from different camps that you attend. And based on that, I want to show you guys some tools that you might not be using at the moment, which you might find useful to you, okay? The first thing I want to speak about is this website. Now there are many websites. There's this SA Papers website where you're going to find a whole lot of past papers. And you're also going to see one that I think you guys are all familiar with, Stanmore Physics. If you guys are looking for past papers, then these two websites are the websites you would like to visit, okay? You're going to find November exams, trial exams, June exams, and so on. At this point in the year, your focus should perhaps be trial exams and November exams, but go and have a look at this website. Now, IEB chemistry and DBE chemistry, in terms of the topics, tends to be exactly the same. The IEB just tends to test a little bit more grade 10 work. For example, types of bonds, ionic, covalent, metallic, and so on, types of intermolecular forces, they test that as well. But for my learners who are writing government papers, if you're trying to get high marks, if you're really trying to test yourself, to see if you're actually intelligent and able to adapt to different situations, I highly recommend that you go to this website, this SA Papers website, and there you're going to find a whole lot of IEB papers with their memos that you can try, okay? And this is just to expose you to something a little bit unfamiliar, where you're using exactly the same knowledge and applying it. It's going to help you with those level 4 questions that you might come across in a DBE paper. Okay, there are memos as well, so make use of the memos. Please mark, otherwise you won't know where you're going wrong. Then guys, a lot of you know about Muniz Nkosi. Please use his YouTube channel. I would recommend him for that foundation knowledge. He tends to introduce you to the topic very well. So please, if you don't know him, go and check out his YouTube channel. I think he has covered all of the different topics that we cover in physical science. Kevin Math, who is now Kevin Math Science, okay? This I would recommend for exam prep because he tends to go through past papers. So if you're looking for someone to guide you through past paper questions, go and try Kevin Math, alright? Back in my day, these humans did not exist. It was me and my teacher and no one else. You guys have the internet. I did not have the internet. Use the internet, please, and the humans that put content on the internet for you, okay? Then you guys will learn later as well about the Junior Techie website. I think there is a session for it. But if you're struggling with acids and bases, I'm going to tell you guys up front, this was a problem for me when I started teaching, and the person who helped me was Dr. Sarita Swanapu, who made these videos. I watched these videos, and because I watched these videos, I was able to teach. So if I, from these videos, can learn how to teach acids and bases, I'm sure that you guys can learn how to understand it and apply it in an exam. So make use of the Junior Techie website as well. Okay. Now, I would like to talk about this. And the reason I'd like to touch on these circles of control, influence, and concern is because I've come to realize you all have different teachers, your teachers teach you different things, and all of us as teachers know a little something, but not absolutely everything, right? Guys, there is only so much that you can control. And I really want you guys to start to focus on that circle of control and sort of forget about the circle of influence and the circle of concern. So there are things that you are worried about. You are worried about the economy and you are worried about all of the wars that are happening in the world, but you can't do anything about them. You're concerned, but there's nothing you can do about them. So at this point in your academic career, I want you guys to detach for a moment. There are things that you can influence but can't control. I'm going to talk about that in a moment. And then there are things that you can control. We want to focus on these things. So what I did is, I went to my friend called ChatGPT and I asked ChatGPT, what are some of the things that grade 12 learners can control? Okay, and you've probably heard this before, but I'm here to remind you. Firstly, guys, you have control over your study habits. Your time management, you can control that. Setting goals, you can control the goals that you set. Creating a schedule. If you have not set a study timetable, that's your first problem. You need to be very skilled in that regard, because when you go to university, you're going to be studying and studying and studying and studying, and you need to know how to study and work around your time. The next thing they mention here is the effort put into exams. A lot of you think that you can control your mark, that you can control your grade. I'm here to tell you, you can't. You can't control the mark that you're going to get at the end of the year, because you have no idea what we're going to put in your final exam. But you can control your effort. You can control how much you study, what you study, when you study. And in doing so, you can influence your grade, but you cannot control it, okay? And this is very, very important for you guys to understand. You think you can control your grade, you can't. Detach from the mark and focus on your effort. Am I putting in the effort, and am I putting in the right effort? So I teach at a sports school, so most of my learners would like to become professional athletes, and this is the example I make. Let's say that you are a swimmer and you would like to compete in the Olympics in 2028. Now you have 4 years and you decide over the next 4 years for 5 hours you are going to train by sprinting on an athletics track. That's what you're going to do. Remember, you're a swimmer. If you sprint every single day, chances are that you will probably be fit and you're going to be very, very tired. So effort is there, but you're not going to win a gold medal at the Olympics for swimming, because swimming requires a different type of training. And what some of you do is you put in so much effort and oh, I'm so tired, but your study skills are not correct. The way you do things is not working in your favor. You're too stubborn to change it, And that is why at the end your grades are not according to your goals, all right? So focus on your effort, but also focus on what type of effort you're putting into your exams, all right? We have control over our attitudes and mindset. We know that. Not everyone else's. So yesterday we spoke about different teachers, and I said to you guys, sometimes your teacher might teach you something that's a bit off. If you go to the learners I taught 5 years ago and you ask them about Miss Barton, they will probably say she was a terrible teacher, okay? Because it has taken me 5 years to become the teacher I am today. But my kids were very kind. They didn't run to the principal and say, hey, that teacher, we have to fire her, all right? They were kind towards me and they allowed me to grow. So all of those teachers that you guys have labeled as bad, whether it's for physical science or a different subject, please remember they're just human. But guys, what I want to say is, some of you have had the same physical science teacher for 3 years. And from the very beginning in grade 10, you decided this teacher is bad. And what you've done is, from grade 10 up until yesterday, you complained about the fact that your teacher is bad. Instead of taking responsibility for the situation and saying, hey, my teacher doesn't communicate in a way that is effective to me. So you know what I'm going to do? For the next 3 years from grade 10, I'm going to self-study. I'm going to get my friends to work with me and we're going to conquer the syllabus so that when we get to grade 12, we succeed. But no, some of you just, hey, my teacher's bad. Oh, my teacher, my teacher, my teacher. Guys, when you are 52, you're still going to be blaming your teacher because you didn't get into university for the course that you wanted and so on. And by then, your teacher will be chilling in the ground, okay? And you will still be complaining, all right? It's very dark, but yes, that's how it goes. Please, guys, you need to take responsibility for your own lives, okay? Then, guys, participation, you guys are here, so we don't need to talk about that. Asking help, a lot of you struggle with this. I'm going to give you guys a hint about that. Your health and wellness. Some of you, I'm sure, some of you are smoking, some of you are vaping, some of you take a drink once in a while, okay? But you want to go to university and you want to get into grand courses and you want to get the best jobs in the world, but you're damaging the vehicle that you use. This is all that you have. So you guys need to change your habits and you need to decide to do things differently. Otherwise, all of this is for nothing. We're wasting our time because in 20 years' time, your lungs will be giving up, okay? Or your liver will be failing. Let's not do that. Let's take care of the things that we can control, okay? You need to learn to manage your stress. I suffer from anxiety. Most people don't believe me because I am standing in front of you. I struggle to socialize. It's not something that comes to me naturally. But I've learned to manage the anxiety. The stress will always be there. What you guys need to do is learn to manage the stress. Okay, I'm feeling stressed. So what I'm going to do is, I'm going to do 10 jumping jacks and then I'm going to feel a bit better. Okay? Or I'm going to get a stress ball and then I'm going to feel a bit better. Or I really, really love my mom and she makes me feel calm when I'm in her presence. Mom, come sit here next to me when I study physical science. Okay? You do things to manage your stress. But I'm telling you guys now, stress is not going to go away. So you guys must adapt and get stronger. Okay? Your behavior towards your teachers, I've spoken to you guys about that. There's some teachers that might not be your favorite. Guys, teachers are like fruits and vegetables. In general, people tend to prefer the fruit, because it is sweet. But if you are diabetic, the fruit can kill you, okay? The veggies are nutritious, but some of us experience them to be bitter and we don't like the texture. Teachers are similar. Some of us say, open your mouth, we put the food inside, we help it go down, we add the stomach acid to digest it, we do everything to assist you, and in doing so, we rob you of the opportunity to be independent. Some of us are not very good at communicating to our learners. But for those learners that take responsibility, we teach you to be independent. We teach you that you in yourself are capable, that you yourself can study, that the syllabus is not beyond you, okay? So yes, some teachers you like, some you don't. It's just like in school, some people are your friends, some are not. We have our favorites. Let's work with what we have. Like I spoke yesterday, we're all on the sailboat, and the wind blows and the weather is cold. But we can harness the wind so that we can arrive at the destination we so much desire, alright? So all we've got is what we've got. That's what we've got. But we need to take it, and in Jim Ron's words, we turn it into the miracle of our futures. Okay. Career paths and choices, guys. You can choose which career, which degree, which course at university you're going to apply for, but you have no control over the entry. You have no control over how the course is going to go when you get there. So detach and just do your best. Too many of you focus on the grade, the mark that you're going to obtain. And in doing so, you forget that you are here to learn, right? So on the note of learning, I know that some of you do not like the subject physical science. My advice is that you need to start to become interested in it. So instead of going onto Instagram and watching random videos about random things that have nothing to do with grade 12, right? Instead of going on to whatever, go onto YouTube and start to watch videos on chemistry, interesting ones. Go start to watch videos on physics, interesting ones. I did that for a month, and by the end of the month, I was a different person. For 10 minutes every single day for a month, I decided to go onto YouTube instead of Instagram and TikTok and watch videos on physics, chemistry outside of the syllabus, about astronauts in space, about particles that are smaller than protons and neutrons and electrons. And suddenly, the syllabus was interesting. So gain an interest and focus on learning rather than the grade that you have absolutely no control over. Okay, now, just a hint. If you are addicted to your cell phone, right? If it's serving no good purpose in your life, turn it to grayscale. So there's a setting on your phone where you can take your cell phone from the pretty color that your brain is so much addicted to and make it black, white, gray. And you're going to see TikTok, Instagram on grayscale is very boring. Okay. So I highly recommend that if you're addicted to your cell phone, change your cell phone to grayscale. It's going to help you a lot. Okay. Now my last exam skill sort of thing that I want to speak about is, so at our school, because our kids are training all the time, they'd like to become professional athletes, they have very, very little time. Okay guys, our school starts at 9 o'clock, because before that our learners are training. It ends at 3, and after 3 o'clock they go back to training. It's very intense. So they don't have a lot of time to study. So this is what we recommend, and I think that at this point in the year, it will be useful for you guys. You want to study physics, but you want to study it effectively, because this is not your only subject. You have 6 other babies that you care about much more than physical science. My advice is, you sit down and you try a past paper. A recent one is better because it's probably set by the same person who will set your paper for this year, okay? You sit down for 3 hours straight, you try that paper, you time yourself, you make sure you complete it within the 3 hours. It's a long time, I know. So you sit down. After that, immediately after, you mark. You see which areas are your problem areas. And when you start to study, you're going to begin with those. You then know which sections are for revision and which sections require a significant amount of practice. As a group, when we are done marking your exams, what we find every year is you tend to battle most with content that is taught after the first term. And the reason is very simple. First term, we test you guys on Newton's laws again most of the time, but first term work is also tested in the second term, June exams. It is tested in the third term, trial exams, and then it's tested at the end of the year. So why do you love Newton's laws so much? It's not because you actually love the laws. It's because you understand them. And why do you understand them? It's because you've been practicing them since grade 11. So you guys need to spend enough time with the other topics so that you can improve. Okay, now when you are done with that, let's say that we are looking at a past paper, any past paper. If we are looking at one of these, for example, once you've established which topic is your problem area, I advise you guys to do the following. Let's say that we are looking at question number 2. You're going to see question number 2 is out of 18 marks. If I'm not mistaken, you guys have about 0.8 minutes per mark. So time yourself. You can give yourself about 18 minutes if the question is out of 18 marks and then you want to stop. Okay, more or less. So time yourself so that time management is not a problem. But when you're done with question number 2, don't go on to question number 3. First, mark question number 2. Your brain tends to hang on to the stuff you practice. You see, you guys see me today, yesterday, you're not going to see me for a very long time. If you pass me in a year's time, you're not going to know my name because you're not going to practice it. But if you decide to finish a whole lot of questions on nomenclature rules over and over and over and over again, and you practice them wrong, and then you spend 2 minutes marking, your brain will remember the mistake because you practiced the mistake over and over and over again. You need to spend almost as much time marking and correcting yourself as you do trying the questions, okay? If you make a mistake, you don't just mark it wrong. You're going to go and fill in the missing words, highlight the missing words, fix the calculation, spend time correcting yourself, otherwise you will repeat the same mistake over and over and over and over again, alright? Then guys, we are not in grade 2 anymore. You see, in grade 2, when we were marking, we wanted to mark everything right. So since we were busy in pencil, what we would do is, there was supposed to be a plus sign or minus sign, quickly erase it. When we're marking, change it, and then we tick it right. Okay, we love those ticks. Crosses, really, they hurt us when we're grade 2. Now, at this point, you guys love crosses. If one word is missing, mark it wrong, alright? Rather, you be strict with yourself and be surprised in the final exams than be lenient and say, I feel like I got this mark. It looks more or less like the memo. Tick. Don't tick. Don't be lenient. You must mark yourself very strictly when you are practicing. Okay, so that's just a little bit of background stuff. We're now going to move on to the actual chemistry exam. Okay, so again guys, our goal here is to learn how to answer an exam paper, not so much content. Just something that is different in terms of the cognitive levels is the following. If you are looking at a chemistry paper, the percentage recall questions, which tend to be definitions, is exactly the same. Papers are not always completely balanced. Like last year, there were more calculations in the physics exam than there should have been, right? They're not always perfectly balanced, but 15% of your paper definitions. After that, if you are looking at a chemistry paper, 40% is level 2 questions. Level 2 questions are those that test your understanding and will most likely require you to answer in words. So what are you going to do? Please, I beg you guys, no paragraphs. You must answer in bullet point form. Please, if you're one of those people that writes a nice essay for your teacher, stop doing that. You write bullet points. It's not only going to help the marker who you don't know to mark your paper, but it's going to help you to identify the points that you've made, and if you've made enough points according to the mark allocation, okay? So bullet points, please. Now, I realized yesterday not all of you want to get into science courses. You might be taking physical science, but some of you just want to just pass this thing and get through this thing so that it at least doesn't bring your APS score all the way down. But your concern is not really physical science, you just want to pass it. If we are looking at a chemistry paper, if you learn all of your definitions and you can explain yourself beautifully in words, then we have approximately 55% for our exam. Okay? We then just need to get a few calculations right, and we've got our 60%, okay? So study and write your exam according to a strategy, especially if your goal is just to pass. Check the different types of questions that are asked in an exam and focus on those that will guarantee you your marks, okay? In terms of calculations, we're not so strict about calculations and rounding off in physics, because there we're dealing with big objects. Chemistry is very tiny little particles, and because of that, if you round off too soon, we have a big problem. Grade 12s, please only round off at the end. Until you are at the end of question 2.2. If it's a multi-step question, and first you have to calculate number of moles, then concentration, and then pH, for example. When you go from number of moles and you get that answer, don't round off. 5 or more decimal places, please. Okay? 5 or more. You use that in your next calculation, 5 or more decimal places. And when you are at the end, when you've calculated that pH or whatever, then you round off to 2 decimal places or more. But in between a multi-step question, no rounding off. We do penalize you. We take away marks, okay? I know you guys understand the language of marks. You round off in between in a question, you're going to lose marks. I'm not saying 2.1 to 2.2. When you're done with 2.1, you round off. When you're done with 2.2, you round off. But if 2.1 is a multi-step question, do not round off in between, or you're going to lose marks. And then again, we have that 10% of problems, which is your level 4 questions. We're not going to stress about that unless we want a 90% plus. Okay, are there any questions? Yes?
So let's say you do round off, but on your answer book, but you still use the original value, in the rest of your calculations. Would you still use these ones?
You probably won't. So guys, this question is, let's say that you round off when you write it down, but when you perform your next calculation in the multi-step problem, you use your answer, not what you wrote down. Will you be penalized? Probably not, because in a multi-step problem, we don't mark the answers in between. Okay, it's a little bit, but you shouldn't be penalized. Okay, are there any other questions? Okay, let us move on then. So let's say that you just want to pass, guys. Matter and materials in a DBE paper is organic chemistry. If you want 40% for your paper, please master organic chemistry. Organic chemistry, 40% of your paper. Everything else is the other 60%, and organic chemistry tends to be a lot of theory. So please make sure that you get your 40% organic chemistry. Okay, now, ChatGPT. I know that you guys use this for English and all of the other subjects, but for those of you that, when you are studying, find that you have a problem, and this tends to happen with multiple choice especially, and you just don't know why you're getting it wrong, and you don't know why the answer is B instead of C. Because I'm the only physical science teacher at my school, I often get places or put in spaces where I don't quite know the answer and I need to find out. And this machine has been my savior, okay, in that regard. So please, guys, make use of ChatGPT. Enter things into it. If you have any questions that you can't get an answer from a friend or your teacher, use ChatGPT to help you with those misconceptions, to help you to understand. You can ask ChatGPT, how do I calculate pH? And it's going to tell you, okay? So please make use of it. Just remember, AI does tend to make mistakes as well. So be careful, make sure that it makes logical sense, okay? Now guys, today we are going to be starting off with the end. Yesterday I started off with the beginning of paper 1. Today I'm starting with the end of paper 2. So we are looking at redox reactions and galvanic cells first. If you look at your summary booklets, you're going to see this information on page number 20 and page number 21. in last year's DBE paper, the worst answered question was question number 8, if I'm not mistaken, or 9. But it was this question on galvanic cells and redox reactions, if I'm not mistaken. Okay. So guys, firstly you need to understand your definitions. We have that oxidation is a loss of electrons, reduction is a gain of electrons. If you are asked to define oxidation or reduction in terms of electrons, you write that down, okay? They are specific, so make sure you know which definition they're looking for. But if they ask you to define oxidation and reduction in terms of oxidation numbers, then we say oxidation is the increase in oxidation number, while reduction is the decrease. It depends on what they ask. Pay attention to the details. On that note, guys, sometimes we ask you to write down the symbol. Sometimes we ask you to write down the name. If you write down the symbol for sulfuric acid, when we ask for its name, you get 0. If you write down the name sulfuric acid, when we ask you for the symbol H2SO4, you get 0. Pay attention to the instructions. I know you want to take a chance, but we're not lenient when it comes to instructions, especially when they're clear. Okay, now the best way to remember this is either oil rig. Oxidation is loss, reduction is gain. Some of you instead learn Leo Ger. So loss of electrons is oxidation, gain of electrons is reduction. You choose what works for you. I'm more familiar with oil rig, so I tend to use that one. Okay. Then we have what we call oxidizing agents and reducing agents. I would say the most confusing part of redox reactions, electrolytic cells and galvanic cells, is the terminology. I don't understand why chemists had to make it so confusing. Okay. But this is what we know. We know that the oxidizing agent is the substance that is reduced. And the reducing agent is the substance that is oxidized. You see, the key word here, grade 12, is agent. Agent meaning it causes something to happen. So let's say that we have a corrupt human being and we have a group of individuals that are poor. What's basically happening here, if we're talking about this oxidizing agent, reducing agent, is we would say in this case that this human being, although he has the money, is a poverty agent. Because he causes the family to be poor. Okay? He himself is not becoming poor, but as a result of him stealing the funds, he is a poverty agent, alright? So if we are talking about the oxidizing, or let's say reducing agent, we say the reducing agent is what causes another substance to be reduced when it undergoes oxidation. So this gentleman over here is a poverty agent because he causes someone else to be poor when he enriches himself. Okay. On the other hand, our lady over here would be an enrichment agent. I don't know which word to use there, but she is the reason that he is becoming rich. We use the term enriched or rich agent, however you want to say, but this human is losing the money and causing someone else to have money. It's exactly the same when we're looking at these agents. We name them not according to what they themselves undergo, but what they cause the other thing to do. The oxidizing agent causes something else to be oxidized. The reducing agent causes something else to be reduced. Okay. Then we have, guys, the anode, which is where oxidation takes place, cathode, where reduction takes place. We make use of anox and red cat. Anode is where oxidation takes place, reduction takes place at the cathode. There's lots of things that we use to help us. But just so that you guys understand, the anode is called the anode because anions move towards it. Anions are negative charges. The cathode is called the cathode because cations move towards it. Cations are positively charged ions. Alright? It's not about whether it's positively charged, a positively charged electrode or negatively charged electrode. That's not where it gets its name. It gets its name according to what type of ion migrates towards it. Okay? So on that same page, you're going to see a summary of table 4A and table 4B. My advice is that you choose a table, master that table, and as soon as you have mastered that table, try a different one. Okay, so if your teacher has taught you by making use of table 4B, which is the one that I use, my learners have become specialists at using table 4B, but I advise them before they get into the exams to try a question using 4A, because sometimes as part of the problem, we take a snippet from the table and ask questions about it. And that can be from table 4B or table 4A. So please don't become too comfortable with your table. If you are familiar with table 4A, my advice is when you look at your formula sheet at the start of your exam, lightly cancel 4B out, lightly, because you might need to use it. If it's the other way around, lightly cancel out the other one so that you don't get confused. The difference between the two tables is in table 4A, we have the positive cell potentials at the top, negative at the bottom, and the other, negative at the top, positive at the bottom. But the information that they contain is exactly the same. Okay, so if we are looking at either table, the first thing you guys need to understand that you sometimes miss is all of these things on the left-hand side, they are what we call oxidizing agents, which means that each of these things undergo reduction. They undergo reduction. The things on the left-hand side, they undergo reduction. If we're looking on the right-hand side, these are all reducing agents, which means they themselves undergo oxidation. Okay? We compare reducing agents to reducing agents, and we compare oxidizing agents to oxidizing agents. What you guys tend to do in your exam is you switch between them, and you compare reducing agents to oxidizing agents in the level 2 questions, and then you lose your marks. So I'm going to go through that with you. I'm going to try my best to explain it to you, but the tables are basically exactly the same. The difference is just where the most positive reducing potential is and where the most negative reduction potential is. Okay, you're going to see on that page, I show you the steps that you can use to write down the balanced redox reactions. I'm going to apply this instead of explaining it to you right now, but just note that it is there. And I now want to refer you guys to page 21, which is this page. A lot of the session is going to be a lot of theory. My assumption is that you guys did this recently, so I'm trying to refresh the information. Things that you don't understand, I'm trying to assist you with that. And again, just show you guys how to tackle these problems in an Excel. In a galvanic cell, we have a spontaneous reaction, and it is exothermic. Take your cell phone battery, for example. Some of you have cell phones that are old like mine, and after you are done charging it, during the course of the day, it tends to warm up, right? My sister actually takes her cell phone and puts it in the fridge. I'm not sure if that's a good practice, but her battery gets so hot that she puts it in the fridge for like a minute, okay? So, spontaneous reactions, exothermic, they are giving off heat, okay, in your galvanic cell. We know a galvanic cell is a cell in which chemical energy is converted to electrical energy. It's a spontaneous reaction. Your cell phone operates with its battery throughout the day by itself because the reaction is spontaneous. An electrolyte, guys, an electrolyte normally is an aqueous solution containing an ionic substance like sodium chloride or any type of ionic substance you can place inside of the water. But something that I did not write down here is sometimes your electrolyte may be molten. So what is molten? If we take sodium chloride, table salt, and we heat it up so hot that it turns into a liquid, we call that molten, and that can also form an electrolyte. Okay, so if we are looking at a galvanic cell, we will be able to identify it because there are two separate half cells. Okay, in your galvanic cell, you guys must learn this off by heart, please. The anode is negative while the cathode is positive. This is how I remember it. I say, if you look at a number line, positive is on that side, negative is on that side. When you look at the alphabet, what letter comes first? A. And C would come after. So I say in a galvanic cell, the anode is negative, the cathode is positive. Okay, we find tricks to help us. This is one of the things that has worked for me. But this only applies to a galvanic cell, alright? You're going to know it's a galvanic cell because it does not have a battery, okay? It does not require a source of energy for the reaction to take place because the reaction is spontaneous. We're going to have our electrolyte and then our salt bridge. Again, guys, the anode is called the anode because there's a mistake here. Negative ions, called anions, flow through the salt bridge to the anode. Please correct that. Okay, negative ions are called anions, not cations. So if we're looking at this zinc copper cell, there are quite a few questions that they can ask us about it. Fortunately, it's already labeled, so we don't need to consult our table of standard reduction potentials. We know this is the anode, this is the cathode, where oxidation takes place, where reduction takes place. But what if I ask you about the salt bridge? Remember, inside of your salt bridge, we have an electrolyte. This is KNO3 aqueous, which means we've taken this salt and we have put it inside of water. And what do salts do when they get into water? They dissociate or dissolve, but the term that we use to distinguish between your ionic compounds and covalent compounds is dissociate. Ionic compounds dissociate, but if you take a covalent substance like HCl and you react it or put it in water, it will react with the water to form H3O plus and Cl minus. When something reacts with water to form ions, we call it ionization. When you take something like KNO3, it's not going to react with the water, but instead interact with it. You guys will remember from grade 11 that water is a polar molecule, and because it is polar, it causes these ionic compounds to break apart. And so this will become K plus ions and NO3 minus ions. The K plus ions were already there in the solid. The NO3 ions were already there in the solid, but what did the water do? It broke them apart. So we don't have ionization. We are not forming ions. We are just breaking the ions apart. So when you see your salt bridge and they say we have potassium nitrate in the salt bridge, please understand that these things are dissociated. There are K plus ions and then there are NO3 minus ions. So what's happening on the left-hand side? The zinc electrode is undergoing oxidation and forming zinc plus ions. So we're going to experience that the anode is going to get smaller and smaller and smaller because the solid is entering solution as an ionic substance, Zn2 plus. As a result of all of these positives that are building up over here, all of these Zn2 pluses, guess what? We have K plus and NO3 minus. We know that negative is attracted to positive. So what we're going to experience, grade 12s, is that the nitrate ions are going to move this way. And because the nitrate ions are called anions, we call this thing the anode. Right. On the other side, what is happening is electrons move this way, and we have copper ions that become copper solid, As time goes by, we're going to experience that the cathode becomes bigger and bigger and bigger. And as a result of all of these positive ions exiting solution, we have a buildup of negative here. And what is attracted to negative? Positive. So the K plus cations are going to move this way, and that is why this is called a cathode. Alright. Are there any questions about that? We okay? Alright. If we go on to the other side of this summary page, you're going to see at the top I have the functions of a salt bridge. Please learn them off by heart and choose the best according to what your teacher has taught you. I want us to look at the cell notation for a moment. Some of you get confused about the cell notation. So my advice to all of my learners all the time is, if you are trying to write down the cell notation, but you tend to get overwhelmed very easily, because you guys know how to write down oxidation half reactions, reduction half reactions, start off by writing the oxidation half reaction and flow from there. So if you're looking at this galvanic cell on the left, if we start by writing down the oxidation half reaction, it's going to be the zinc is going to form Zn2 plus, and it's going to lose 2 electrons. If we write down the reduction half reaction, we're going to have that the copper 2 plus ions gain 2 electrons and form copper. Now you see, if you write this down in the order first oxidation and then reduction half reaction, if you always do it in this order, you're going to see you'll be able to follow this and write down the correct cell notation. Our anode is the zinc. It's a solid, so between it and the oxidizing agent, we're going to draw a line, meaning a phase break or a phase change. We're going from solid to something that is aqueous. That is why we draw in the line. After that, so notice, I just wrote this down. What is formed is what we call the oxidized species. So next on the list, I'm going to write down Zn2 plus, which is aqueous. Okay? We then have the salt bridge. Now flowing from this, the oxidizing agent is this one over here. So next I'm going to write down Cu2 plus. It's aqueous, so we have another phase break. And next we need to write down the cathode, which is copper. Okay, in terms of this, if you always write down the oxidation half reaction, then reduction, you'll have no problem writing down the cell notation. Please remember, when your electrode is not a solid, we're going to be making use of platinum or carbon as electrodes. Now, a few years ago, I know you guys don't have this in your booklets, but I just want to point it out to you for in case. I think this was in 2020 or 2021. My learners arrived in their trial exam, I think it was, and they saw this. And they had no clue what was going on. Okay. Here they say we have a galvanic cell. And the standard conditions, blah, 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 represented by the cell notation given below. They showed an X and they showed a Y. And in the next question, they asked, what is X and what is Y? And my learners were like, I'm not sure, I'm going to guess. And a lot of them guessed incorrectly. So looking at this, you must please pay attention to how many species are written down, okay? And based on that, come to your conclusion. You see on the left-hand side, we have the oxidized species and then the salt bridge, which means that this has to be the anode. And since zinc 2 plus, right, zinc can form a solid, the electrode here is just zinc solid. And there they were okay. But then they came to this side, and this is what they thought. They thought that this was the reducing agent. Okay, the whole thing. What is actually happening, and I'm explaining this so that you guys don't arrive in an exam and feel like my learners felt. This comma has replaced the straight line. And the reason why we've used a comma instead of a straight line is because the phase change. Okay, you see this is aqueous and that is aqueous. So looking at this over here is the reducing agent. This over here is the reduced species. So this is what is formed. This is what is formed. Did I make a mistake? Yes, I did. I think I should have written down oxidizing agent. Yes, I did. Sorry, guys. I should have said here, this is the oxidizing agent. And this is the oxidized species. My apologies for that, okay? So what is happening on the right-hand side is Fe3 plus gains an electron and it forms Fe2 plus. But the problem is, and the reason why they've used a comma is because both are aqueous. Now, if you find that your oxidized species is not a solid, it means that you're going to need an inactive electrode to connect the external circuit with the copper wire to the solution inside of your half cell. So why? What do you guys think why should be? Platinum or carbon? One of the two, okay? But this comma doesn't mean that both of these things are the oxidizing agent. That is what a lot of learners thought. Please be careful, all right? We use the straight line for phase changes, and we use a comma when the phase is exactly the same. Okay, so going back to this, I just want to point out a few more things. Standard condition. So you guys will see at the back of your summary booklet is the formula sheet. If we ask you guys for standard conditions, it's very easy to remember the concentration as 1 mole per decimeter cubed. It's very easy to remember the pressure as 1 atmosphere. But please note that this is not in your table of constants. You take what is in your table of constants, right, here at the end, if I can show you. If you are looking at your formula sheet, over here we have a temperature, 273 Kelvin. This is not the standard temperature for a galvanic cell. This is 0 degrees Celsius. Galvanic cell is 25 degrees Celsius. So you are going to take the value in your table and add 25 to it to get 298 Kelvin. Please learn this off by heart or remember to add 25. But this is not from your table, you must learn it. Okay, the standard hydrogen electrode, I'm not going to say much about it. Learn it, understand what it is used for. In terms of the cell potential, I'm sure you guys know how to calculate the cell potential. But a mistake you guys make in your exams is you write cat, N, red, ox, red H, red, or ox age, red H, and then you don't get your formula mark. You have to write this out fully. Cathode, anode, reduction, oxidation, oxidizing agent, reducing agent. If you shorten it, they take away your marks. Anything that you use from your formula sheet, you write down exactly as it is on your formula sheet, or you lose a mark unnecessarily. And that might be the mark difference between a 79, 80%, or a 39, 40%, or a 29, 30%. So please don't neglect what you copy down from your formula sheet. The last thing is something we don't spend a lot of time on, but it does come up in your exams quite often. Cell potential and chemical equilibrium. When a battery is flat, it is not because the reaction is complete. Okay? What has happened is we have entered a state of chemical equilibrium. That is why you can take your cell phone, where its battery has reached equilibrium, attach it to a plug, and allow electricity to reverse the chemical reaction, so that we again have a whole lot of reactants and very little products, and the forward reaction will be favored throughout the course of the day when you use your cell phone. So firstly, looking at all of this, please understand that if your cell phone battery or any battery is at 0, then it is at 0 and therefore flat, okay? If the chemical equilibrium or potential is 0, it's because it is flat as a result of us reaching chemical equilibrium. Okay, very, very important. A flat battery has reached chemical equilibrium. So based on that, we can ask you guys questions involving the Chatelier's principle in this problem, in this question on galvanic cells. If you have a cell or battery that is flat, and without connecting it to an electric circuit or a battery or the wall plug, you want to ensure that the cell potential increases. You can do so by adding more reactant, because then the forward reaction will be favored. You can take out reactant, not that. You can take out some of the product, don't ask me how, but if you can reduce the amount of product, then you can ensure that the cell EMF goes up once again. If you reduce the amount of reactant, the EMF is going to decrease because the reverse reaction will be favored. If you increase the amount of product, the EMF is going to decrease again because the reverse reaction will be favored. You can be asked the Chatelier's principle in this section of your exam. Yes?
Is it possible to relate this to like an increase in concentration of the electrolytes of one half cell and another?
Yes. Yes. So here, when we speak about what is increasing, if I go back to this, if we're looking at this cell, and let's say that we have entered chemical equilibrium, right? What is happening over here is, as time goes by, we're going to build up a whole lot of Zn2 pluses. Okay? And our reactant called zinc, this is the reactant, it forms this product, okay? This electrode is going to become thinner and thinner and thinner and thinner. So the amount of reactant we have is decreasing. On the right-hand side, what we have is that this reactant reacts to form copper. And as a result of it forming copper, the concentration of our electrolyte, or at least the copper ions in the electrolyte, is going to decrease, okay? So this is reactant. If I would like for this specific cell to increase the cell potential, I would like to have more reactant. And in this case, my reactants are zinc solid and copper 2+ ions. If I'm talking about products that cause us to get to equilibrium faster, then we're talking about the zinc 2+ and the copper solid that has formed, okay? So, to favor the forward reaction, I add more reactant, okay? If I would like this cell to reach equilibrium faster, I'm going to go and increase the amount of product, okay? Normally within the electrolyte itself, we tend to not mess around with the electrodes, okay? There was another hand that was up. Does that answer your question, Toto?
Yes.
Okay, yes.
Why is it that when the reverse reaction is favored, the EMF decreases?
The what decreases? The EMF. Okay, so the question first, I don't think I'm going to answer you in the best way possible. Okay, chemistry is not my best friend. But the reason why we have a voltmeter reading and an EMF in the first place is because reactants can form product in what we call a spontaneous reaction. But the reality is that this reaction can take place that way as well. So if ever you want a high voltmeter reading, you want this reaction to take place, the forward reaction to take place. So anything that you do to increase the rate of the reverse reaction, remember, if you increase the rate of the reverse reaction, you decrease the rate of the forward reaction. So anything that you do to increase the rate of the reverse reaction will cause the EMF to go down. Because EMF is about the forward reaction taking place. The better the forward reaction can take place, the higher the cell EMF is going to be. Is that okay-ish? Right. Guys, chemistry is not my best friend because it has lots of exceptions. It loves you and then there's an exception. We do this, but sometimes we don't do it. So chemistry is not my strongest point. You guys will have lots of questions and all I can promise is to do my best to answer them. Okay? Yes.
Ma'am, say you connect the galvanic cell to an electrolytic cell,
Yes.
right? Is there still need for a salt bridge?
Yes. Because otherwise your circuit's going to be open.
But doesn't it, how, okay, well, wouldn't you connect like a wire with the electrode into the electrolytic cell and then you sort of bypass the salt bridge? Or how does that work?
So let's say that you would like to take this and connect it to an electrolytic cell. If you were to do so, can you see where this voltmeter is? You're going to place your electrolytic cell there, and remember it's going to have its 2 electrodes, right? This electrode will be connected there, that one will be connected there. Okay, so what is going to happen is, we're going to have electrons leaving, they're going to move this side, and electrons will build up. We'll have ions that move as part of our current flow, electrons moving that way, and moving around to this side. But if the salt bridge is not there, suddenly we're going to have an open circuit. Does that make sense?
Now, can you keep the voltmeter and then connect it, like add 2 wires with an electrolytic cell?
Yeah.
In
So
like
maybe
in the
put
middle?
the electrolytic cell here
Yes,
in the
and
middle.
do you still need it? Can you do that?
The problem is that a voltmeter has a very high resistance and current can't flow through the voltmeter.
Yeah.
In which case I think you would ask me, can we put an ammeter there?
Yeah, we just remove the voltmeter, just put a wire. Like you don't need to have a voltmeter.
No, it won't work. The reason why it's not going to work is as follows. Remember, this part is not electrons that are moving. So remember guys, charge or current, sometimes it's electrons that are moving, sometimes it's ions that are moving. And just as a result of the fact that the negatives that move over here, just because they are not electrons but rather ions, we're going to find that it's just not going to work. Okay? It's a bit of a lousy answer, but I hope that it helps.